Hi, Algebra 2. Hopefully you just followed the directions on the little Desmos activity, and we have an idea about these absolute value graphs now, right? The V shape, that's what that's supposed to mean right there. We talked about a little bit in that first little video about where absolute value comes from and how to actually evaluate expressions that have absolute value, but now we're talking all about graphs. In general, we call this the standard form of an absolute value graph. We have y equals a times the absolute value of x minus h plus k. Okay, we have three different numbers in there, three different variables that are going to change from problem to problem. A is going to be some number, h is going to be some number, and k is going to be some number. We have two general goals here with these notes. One, if I give you an equation, you got to be able to tell me the vertex. Two, if I give you the equation with numbers in here, I want you to be able to tell me how it's been changed. How is this graph different than the parent function, that very first one you did on the Desmos? How is it different? How do these numbers shape and change my graph? Okay, so let's start with the first goal, the vertex. The vertex from our little thing is by definition, the very bottom of our V shape on absolute value, or the very top of our V shape of our absolute value. Okay, the peak or the valley, the very top or bottom. In our equation, it's always going to be whatever h and k are. So for the very general form, y equals the absolute value of x, doesn't look like it's there, but it is. Sometimes when they're not there, they're invisible. So this says the exact same thing as y equals 1 times the absolute value of x minus 0 plus 0. Those two things are exactly the same. And now this is in what we call standard form. And we can see that the vertex, h and k, are right there. It's 0, 0. And it is. When you guys graphed that one, it was the very middle of your graph. The vertex was at the very middle, which we call the origin. Okay, and we have our vertex. So let's practice one. Hit pause for a second, come up with something, write it down somewhere. Y equals the absolute value of x minus 3 plus 11. And then y equals negative 7 times the absolute value of x plus 4. Hit pause and bring it on back. Okay, hopefully you hit pause, and I'm not sure, I can't check it, but I want to go ahead and type in that first one just to kind of check it. And you guys can do this too if you want to, but it's y equals, we said the absolute value of x minus 3 plus 11. Whoa, and it shifted way up there, so maybe I'm in too far. But now we can look at it. So the vertex, the very bottom of my graph, I can look at it, is a positive 3, 11. Now because there already is a minus sign in here, it's like a minus 3. It's positive 3, okay? So what I really want to get across on this, and you guys saw this when you were doing the little Desmos activities, if you put a minus in here, it actually moved it to the right 3. If you put a plus in here, it moved it to the left. So it's opposite of what you would think when it's on the inside of the function. The outside, that made sense. A plus 11 meant up 11. Okay, so going back to this one, we just saw that the vertex of this one was at a positive 3, 11. Sign flip. On this one, okay, sign flip, a negative 4, there's nothing out here. But what did we just say a second ago? If there's nothing out here, it's 0. Okay, I could always add a 0. It's invisible, but it really is out there. So there are the two vertices. That's what we say for a plural form of vertex, the two vertices. Vertex 1, positive 3, 11. Notice the sign flip. And then negative 4, 0. A sign flip, and then that invisible 0. Goal number 1 handled. I give you an equation. You tell me the vertex. Piece of cake. You got this. Okay. The second goal for these notes. I want you to be able to describe how the graph is different. How is it shifted? How is it changed? How is it transformed is the real word you'll use. From the parent function, that general one, y equals the absolute value of x. Okay, so we're just going to rip through 3 examples. We'll probably hit pause and you'll answer some questions as you go, and then we just need to practice. That's what we're looking for. Okay. So here's the first one. How is this graph, pretend you saw nothing, how is this graph different from just the general y equals absolute value of x, the parent function? Okay, well, from what we just talked about, the vertex is usually at 0, 0, but this one is at negative 4, negative 3. Well, we can use that information to help us. The vertex got shifted, so all the points got shifted, and that's the word we can use. Shifted, this was, if it's at negative 4, to the left 4, and down 3. Inside of our function is left and right, opposite of what you'd think. Plus 4 doesn't mean to the right 4. Plus 4 means to the left 4. The outside of the function is up and down, and it's exactly what you think. If it's a minus 3, it's down 3. So we just write that out in words. How has it changed? It shifted 4 to the left, shifted 3 down, and we're done. That's all we're looking for. We're describing how these things change our parent function. Okay, here's one. Y equals 2 times the absolute value of x plus 1. How has this thing been changed? Okay, think about that Desmos activity. Okay, this one we have handled. That's on the outside over here. I'm adding, that's up. That's moving, shifting our graph up 1. The inside hasn't changed at all. That's just the absolute value x. So there's no shifts left and right. But now this number on the outside, what happened on our Desmos activity when you multiplied the outside of the function by a number bigger than 1? If the number's bigger than 1, it made it narrower. And that's the word we'll use, narrower and wider. In this case, if the number you multiply by on the outside is bigger than 1, then our graph will be skinnier. It'll be narrower than it normally is. Okay? So we had this shifted by 1. Multiplying by 2 on the outside made it narrower. That's it. There's really only 4 things we can talk about. Shift it left, shift it right, shift it left and right, shift it up and down, make it narrower or wider, and then the last one was the last thing on that Desmos, and I'm sure I'm going to cover it here, right? Let's see what it is. Here's the last one. This covers all 4. There's only 4 things I can do to change this graph. Here are all 4. Take a minute, see if you can list all 4. Okay, we're back. We can just start here with this one. The negative. That was that last one we were talking about. That flips it upside down. That makes it, instead of a V shape, an upside down V shape. Looks like a hill almost. Multiplying by a half. Okay, if what you're multiplying by is less than 1, or is between 0 and 1, and now we're talking absolute value, but if it's less than 1, we're going to go with, that makes it wider. So upside down, wider, to the right 7, up 4. All right, those are the 4 things. There's a sign flip in here. Remember, it looks like a minus 7. That actually means to the right 7. Our vertex for this one would be at positive 7, comma, positive 4. To the right 7, up 4. So all we do is list all that out. Flipped upside down. So if you can follow my schematic, green, made it wider. Minus 7 was 7 to the right. Plus 4, 4 up. And we're dancing. That's it. Get some practice, just a little bit, and then come back into class and we'll start hammering this stuff down and getting good at it. Moving on.